The morning is cloudy, but it isn't raining. So you grab your bag and head off to work. You're halfway there when it starts drizzling, then raining, then pouring. There's only one thought in your head as you're dashing through wet streets towards your office building. If only I could hop in a time machine and go back in time. I'd have put that umbrella in my bag. Unfortunately, going back in time is not possible. But guess what? We still managed to travel in time. But let's start from the very beginning. More than 100 years ago, a famous scientist called Albert Einstein, I bet you've seen his most popular photo, came up with a theory about how time works. He gave it a nice little scientific name, the theory of relativity. According to it, space and time are linked together. Another point is that our universe has a set speed limit. Nothing can move faster than the speed of light, which is 186,000 miles per second. Okay, you may say, but what does it have to do with time travel? Well, the theory of relativity also claims that the faster you move, the slower you experience time. And several experiments prove this to be true. For example, let's say you have two clocks set to the exact same time. You leave one clock at home and take another one with you while traveling by plane. What's important here is the fact that the plane is going in the same direction as Earth. After your plane finishes its flight around the world, you can compare the time on the two clocks. You find out that the clock that traveled with you is a bit behind the clock that remained on the ground. Because of this, GPS clocks are corrected. GPS satellites travel around our planet at tremendous speeds, around 8,700 miles per hour, and more than 12,000 miles above the surface of Earth. This speed slows GPS satellite clocks down, but the altitude speeds them up. As a result, the clocks on GPS satellites experience time at a rate that is slightly faster than 1 second per second. And if this difference in time wasn't corrected, you wouldn't be able to use GPS to figure out your exact location. In any case, this is probably the closest thing we have to time travel. You see, our planet is constantly moving around the sun at an average speed of 67,000 miles per hour. The sun, along with the entire solar system, is, in turn, circling the center of our home Milky Way galaxy at a staggering 140 miles per second. And the Milky Way itself is also moving. It's spinning at a speed of 130 miles per second. Those are some really dizzying numbers. And now imagine that in order to get to the past, all this space matter must also turn back and return to its original position. Just admit it, it's absolutely impossible. By the way, even though we can't exactly travel back in time, we can look at the past, thanks to NASA's space telescopes. They help us see stars and galaxies that are insanely far away. It takes the light coming from them ages to reach Earth. That's why when you observe those distant worlds, you see what they looked like a long time ago. Now, what if time travel was somehow possible? Wouldn't all the fun be spoiled by the time travel paradox? You know, like finding yourself in the past and accidentally preventing your parents from meeting each other? The problem is that Einstein's theory of general relativity theoretically allows a person to travel back in time and come in contact with their past self, which can potentially endanger their existence. But you can breathe out. Some scientists at the University of Queensland have recently claimed that this paradox might not actually exist. They say that even if you made some changes in the past, the timeline would self-correct anyway. In other words, it would still ensure that whatever event sent you back in time would still happen. One more study claims that even if some changes happened in the past, they wouldn't drastically alter the future. You know how Stephen Hawking said, the best evidence we have that time travel is not possible and never will be, is that we have not been invaded by hordes of tourists from the future. But what if these tourists come to our time, but they do it secretly? You may even have met one of them. Let's see the most famous time travelers. Meet Oren. He's a cyborg who came to us from the year 2050 to stop the coming end of the world. In 2020, he appeared on a TV show where he said the whole world was inside the Matrix. Then he hit the headlines and gave an interview to a popular YouTube channel. As proof that he's a cyborg, he demonstrated his robotic voice, which can be made in a simple computer program. He also called himself We because he declared himself a collective consciousness that had come to save humanity. Oren became famous for his predictions about the near future, but it turned out that many experts had already announced these forecasts earlier. He also said that a huge corporation was suppressing humanity, and we were inside a complex computer simulation. If we don't improve or care for each other and nature, the end will begin in 2050. Oren no longer appears on major shows, but he has a small fan base of people who love all sorts of fantastic theories. Another time traveler is Adam Archin, who came to us from 2045. There was an interview with him on YouTube where he shared some details about the future of the US, after which the video went viral and hit the lines in many newspapers. Archin reported that the last official president of the country would be the daughter of Martin Luther King III, and she would become the greatest US president in history. Another exciting event that Archin announced is supposed to happen in 2028. He said that people would learn about the existence of extraterrestrial civilizations. He added that these creatures wouldn't come from outer space. The traveler also noted that the world would switch to a single digital currency and all cash would disappear. Of course, no one believed him, so the experts conducted a lie detector test. And Adam Archin successfully passed it. He said that he had a chip in his hand to facilitate time travel. An extraterrestrial civilization would arrive on Earth in 2028, and in 2045, people would be closer to robots. The lie detector didn't state that Archin was lying, but this doesn't mean he told the truth, since the device can be deceived with the help of special training. In any case, in 2028, we will find out whether Archin was right or not. All these time travelers arrive in the past and, for some reason, don't use knowledge from the future. What would you do if you could go back 50 years? Perhaps you would invest money in shares of some young company that will become a big, expensive corporation. In that case, everyone would believe that you really came from the past. And by the way, one guy did it. He invested $800 in the stock exchange and made $350 million out of it. This guy's name was Andrew Carlson, and he hit a big jackpot in 2003. However, he didn't manage to enjoy a rich life because the FBI came for him. Andrew sold some stocks and bought others, and did this very successfully. Thus, in a few months, he became a millionaire. The Securities Commission couldn't believe in such coincidences, so it called the FBI. During the interrogation, everyone was sure Andrew would begin to justify himself and say he was lucky. But instead, he calmly replied that he came from the year 2256 with the help of a time machine. Of course, no one took it seriously. But when the FBI started looking for information about this man, they found nothing. Andrew Carlson had no documents. He was not in any database. He just appeared out of nowhere and started making a lot of money. He was interrogated for about 4 hours, and he behaved pretty calmly. It seemed as if he was telling the truth. However, he didn't tell them the time machine's location. When the press found out about this man, he immediately became a celebrity. Well-known news sites began to write about Andrew Carlson. Articles have appeared in Japan, Australia, Germany, the UK, and other countries. And of course, journalists started calling the FBI to find out more details about this guy. And the FBI told them that the whole story was fiction and that there was no Andrew Carlson. Information about him appeared on an internet resource known for its fake news. At some point, the article about the time traveler somehow got into Yahoo, where it went viral. So, as we see, all statements about time travelers are either fiction or a lie. Conversations about such travels appeared thanks to fantastic films and books. Pop culture has greatly influenced this fantastic concept and created several theories claiming that time travel is real. And some people believe that, especially those who are far from science. But what do real scientists think about this? Are such trips really possible? Let's try to find out. Scientists say yes, time travel is real because we're now traveling in time. Time is moving forward and we're moving with it. We call it a journey. But if we need to get into the future or go back to the past, everything is much more complicated here. Remember Einstein's little theory of relativity? It says that time moves relative to the observer and has no constant value. To understand better, here's a simple example. 10 hairs on your head. Is it a lot or a little? 10 hairs in a bowl of soup. Is that a lot or a little? Everything is relative and depends on the conditions. The same thing happens with time and space. If we move at a tremendous speed, close to the speed of light, then time slows down for us. The perception of time becomes different for a person who's running and for one who's standing still. If we're near some heavy object, let's say 1,000 times heavier than the sun, then the time next to this object also slows down, thanks to its strong gravity. In this sense, time travel is possible. If you're an old person and meet your friend as young as he was 50 years ago. Why are you so young? Oh, I've been flying in space at a tremendous speed all this time, that's all. But this doesn't mean that this friend just sat on the ship for 50 years and didn't age. No, time was different for him. 10 years for you on Earth is a long period of time, but for him, these 10 years passed like half an hour. Gravity and speed bend time. For this reason, astronaut Scott Kelly, who spent a year and a half in orbit, became 5 milliseconds younger than his twin brother after coming to Earth. All this time Scott spent inside the ship flying in orbit at high speed, and he was also further away from the gravitational center of the planet. So, time was slower for him by 5 milliseconds than for his brother. Objectively, time always runs at the same speed, but its speed changes inside the perceptions of different observers under different conditions. That's what the theory of relativity is about. But what about jumping into the future or the past, like in movies? Wormholes will help you with this. This is something like tunnels that pass through space and time and can connect different time segments in different places in the universe. They are like cheat codes that can break the laws of the universe. Wormholes are elusive, have different sizes, are unpredictable, appear in space, and vanish. But their main problem is that wormholes only exist in theory and sci-fi and have never been noticed in our universe by scientists.
Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we captured the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?